greenhouse gas emissions. In our resource management program, our kind of mantra is increase resilience by reducing stress, using wildland fire, prescribed fire, things like that, to get our forests back to at least some semblance of their pre-settlement pattern, so that all they have to deal with is climate change, not climate change plus extra growth because fire was suppressed for so long. We have to be careful, though, because if the fires burn too hot, those forests may not come back. What we're finding is that restoration of natural ecosystems in the park may become a moving target in the future. So what can we learn from the past at Grand Canyon? Well, one thing's obvious. Climate has changed throughout the canyon's history. Sometimes it's life itself that drives those changes, whether it's the appearance of oxygen in the atmosphere 2 billion years ago, whether it's the stockpiling of coal during the Carboniferous that caused an ice age during our red wall limestone time. Life can drive those changes. Life must respond to climate changes. And frankly, life always has. Some creatures indeed did become extinct, but others appeared to take their place. Sometimes the process was relatively quick, other times not so much. The Permian extinctions that we talked about, the recovery by some measures took nearly 100 million years before life re-achieved the diversity it had before those extinctions took place. So life finds a way, but it takes time, and we're talking geologic, not human time. Today, we know that change is coming. We might argue about how much that change is going to be, but it's coming, and we have to admit that our understanding of it is incomplete. We don't know the magnitude of the change. We don't know the different ways that things are going to respond to that change, but we're in the driver's seat. We may not be the only thing, but we are the principal reason behind the changes in climates that we see today. So, since we're in the driver's seat, do we know where we're going? And that is a very good question. And now, I'll take yours. Robert.
You talked about hotter and drier in our region and less water. What about water quality? Concentrations of contaminants such as mercury from coal plants, is it likely to increase the concentration of certain contaminants as we have less water?
That's something I haven't seen anything one way or the other on. I know that at Grand Canyon we do measure deposition, both wet and dry deposition. And we have about 2/3 of the atmospheric deposition that we have of air pollutants in the canyon comes as dry deposition already. It doesn't get a chance to get washed out in the air. There is one of the things that they are predicting is an increase in windblown dust. Now, whether that windblown dust will act as a magnet for some of that material that's in the air or not, I don't know. So the short answer to my question is, I really don't know. I haven't seen any projections on that one way or the other. Yeah.
You were talking about Lake Powell. In 2017, it was going to be a minimum
power production. That was, a 50-50 chance. And the key here is based on the current management practices. In other words, when the way the water was managed when the study was done, which was, I think, year before last. There's a 50% chance that the lake level would drop down to the level where the penstocks take off to the power plant. In other words, the minimum amount of water in the lake that they have to generate power. So the dams, both Meade and Powell, they have different levels of inlet. So there's the power level, and then there's the spillways, the power, and then the river works. And so you can drop below that power generating. If you can't get water into those penstocks, you can't generate power anymore. You can still have water out the outlet works. If the water gets down to the outlet works, then you can no longer regulate it, basically. Then that's what's called dead pool. That's the water that you can't get to because it's below the lowest inlet on the lake.
And that was 2020, 2025, the dead pool?
Let me look, I think it was 2021.
2021.
Is that what I said? I make up these numbers so fast. It's hard to yeah, 2021. And that again was a 50-50 chance in that particular study that was done. Mm-hmm. Yeah.
If ponderosa pines are eliminated from the south rim, will pinyon juniper supplant them, or what's the anticipated course?
The projection is actually the juniper will be leading us as well. And this is based on what Dr. Cole is doing. He's at USGS, and he's looking at the seasonality, temperatures, and precipitation, and trying to fit all those together onto the specific habitat requirements for different plant species. And he's also assuming that plants can get to where they can grow, that they can migrate that fast. Which, if you're tamarisk, no problem. You know, Joshua trees have kind of more trouble slinging their seeds, so there's some question there. But yeah, he's looking at ponderosa being on the north rim, pinyon still being on the south rim, but juniper actually retreating down to a place called the Upper Basin, south of Desert View, on the road out towards Cameron, and in the Wapatki area. So there would still be juniper around, but they would essentially be absent within the park itself. The pinyon juniper that we see today is just kind of a chance association of slightly different growth requirements from the two species that are overlapping today, but did not overlap during the Ice Age and would not overlap if carbon dioxide, under the climatic conditions that would result from the doubling of carbon dioxide levels. So it's, two wooden ships passing in the night, so to speak. Yeah.
Is the ozone layer pretty high? I went in Grand Canyon or here in Flagstaff also.
Flagstaff doesn't have the monitoring equipment that we have up in the canyon, but they have done some passive sampling down here in Flagstaff, and it does look like the levels are high. Not as high as what we have at Grand Canyon, but still somewhat elevated.
What do you measure those?
The ones in Flagstaff, it was
Grand Canyon.
at the Grand Canyon, we have a ozone monitor on the south rim out near Hermit's Rest, about 5 miles west of the village. The ozone we get? The ozone at Grand Canyon is an upwind. It's coming to us from metropolitan areas. Most of the ozone forms from a sunlight-powered reaction between other air pollutants. Nothing emits ozone by itself. And so what happens is automobile exhaust contains the necessary ingredients, hydrocarbons and nitrogen oxides. Sunlight cooks those together, makes ozone, and then it drifts on downwind. What we see at Grand Canyon, since ozone is made by sunlight, you expect ozone levels to go up in the daytime, down at night, up the day, down at night. At Grand Canyon, our levels are essentially flat, which tells us that our ozone isn't being made at Grand Canyon by sunlight, it's being blown in from someplace else. And it's probably a mixture of someplace else's.
Given that the park's mission is to protect and preserve, and given the changes that are anticipated, let's say, for example, Abilene coming in, how much discussion is there in terms of management policy changes that might have to be adapted to, like how do you address California's coming in?
In terms of adjusting to, distinguishing what we would call an exotic species from a refugee species, there's been a lot of discussion as to how we should do that, but not any real clear conclusions as to what our path is going to be. So I know that I've listened in, and I'm not a wildlife biologist, so I don't go out of my way, but I've listened in on some of the discussions about that. And there's a realization that we may have to start transplanting, like those Joshua trees that can't move fast enough to get to their new habitat.